You know, when you think of space weather, you probably imagine satellites getting zapped or maybe the power grid going down. But what happens when a single particle, after traveling 93 million miles from the sun, slams right into the heart of our industrial world? Okay, let's get into this, because it's a critical threat to our physical infrastructure that almost nobody talks about.
All right, just for some context here, what we're about to go through is part 7 of a big 10-part series. It's all based on a really detailed report from the team at RFI Detectives who are part of Virtualization Options LLC. We're going to be focusing specifically on what they found in Chapter 7, the impact on our industrial systems.
I know it sounds like a weird, kind of silly question, right? But it actually gets right to the heart of the matter. We're not talking about a little bit of dust here. We're talking about incredibly high-energy particles that can unleash total chaos in the very automated, computer-driven places that make, well, pretty much everything we use.
So to really wrap our heads around the risk, we first have to understand the systems themselves. The best way to think about modern industry is to imagine it has this huge electronic nervous system. It's incredibly complex, it's all interconnected, and that's exactly what we're going to unpack right now.
Okay, here's the bottom line, the most important thing to get. We are not just talking about some computer glitch that forces you to reboot your laptop. No way. In an industrial control system, an ICS, a single malfunction has real, physical consequences in the real world. This is probably the highest stakes environment you can imagine for this kind of problem.
So how does this actually happen? I mean, how can something happening millions of miles away cause a massive problem on a factory floor? Well, it all boils down to a single, solitary particle causing one tiny error. Let's break down the key players in this invisible drama.
First up, you have SCADA. Just think of this as the big picture, the central brain of the entire operation. SCADA systems are those control rooms you always see in the movies, with the giant screens monitoring everything from a city's water supply to an entire car factory. It's the supervisor.
So if SCADA is the brain, then PLCs are the hands. These are these tough, rugged, purpose-built computers that are literally bolted to the machinery on the factory floor. They're the ones telling valves to open, robotic arms to weld, and conveyor belts to start moving. They execute the commands.
And finally, you've got the RTUs, the remote terminal units. And if we're sticking with the body analogy, these are the senses. They are the eyes and ears of the system. They're out in the field, maybe on a remote pipeline or an electrical substation, reading temperatures, checking pressures, and sending all that vital data back to the SCADA brain.
And this brings us to the actual culprit, the single event upset, or SEU. You can think of it as a cosmic bullet. It's one single high-energy particle from the sun that zips in, hits a microchip, and flips one bit of memory from a 0 to a 1 or a 1 back to a 0. It's this tiny, silent, invisible error, but its consequences can be absolutely massive.
Okay, so now let's connect all the dots. Let's see how that one bit flip we just talked about can actually cascade into a potential disaster. It's literally a chain reaction, where one microscopic event kicks off a huge macroscopic failure.
And this just lays it out perfectly. It really is a domino effect. A solar particle slams into a controller, could be a PLC, could be an RTU. A bit flips in its memory. That simple bit flip changes a command. Maybe the command, keep the main valve closed, suddenly becomes open the main valve. The controller, just doing its job, executes that wrong command, and boom, suddenly you've got physical damage or a catastrophic system shutdown.
And a source report, it does not mince words on this. This isn't some academic theory. They say a malfunction can lead to wrecked equipment, chemical spills, and, in the absolute worst-case scenarios, it can endanger human lives. That is the stark reality of what's at stake here.
So what this all does is shine a huge spotlight on a hidden risk that's built right into the fabric of our modern world. Our relentless push for efficiency has created these incredibly powerful systems, but they also have these unique vulnerabilities to the simple cosmic reality of living in our solar system. And a huge piece of the problem comes down to our older legacy systems. A lot of those RTUs, the senses we talked about out in the field, they're old. They were designed and built long before anyone was really thinking about space weather as a serious threat. So they don't have things like modern error-correcting memory, which means they have no way to fix a bit flip. And since they're remote, a failure might not even be noticed until it's already caused a massive problem.
So look, if there's one thing to take away from all this, it's this. This is not science fiction. This is not some futuristic what-if scenario. It is a real, fundamental risk that is baked into the systems that provide our power, our water, our fuel, and all the stuff we buy. The very infrastructure we depend on every single day is vulnerable.
And all of this leaves us with a really critical question we have to think about. We know that major solar storms aren't a matter of if, they're a matter of when. So when you look at these vulnerabilities, you just have to ask, are we really ready? Is our critical infrastructure actually resilient enough for what's coming?